next video is on average and instantaneous velocity and speed, which is covered in chapters 2-6 and 2-7 in the textbook. So first, to start with average velocity. So velocity is a vector, so velocity includes both a magnitude and a direction. So remember, for the direction part, since we're only dealing with one-dimensional motion at the moment, we can just denote this with a positive or a negative. So that tells us, since we're only moving along a line, the positive or negative sign indicates which direction we're going. So first, we're going to start with average velocity. So average velocity is how far you went and in what direction, divided by how much time it took. So to be specific about it, velocity, we're going to use a v, so it has a magnitude and a direction, it's a vector, so we put the arrow over it to denote it's a vector. And your textbook likes to use this little AV to indicate average, which is how I like to do it also. And since we're only dealing with one-dimensional motion at the moment, we put a little x here just to remind us that this is only the x part, so it's only one-dimensional. So what we do is we take the displacement, so delta x, so remember x is our position, our location, and delta x is our change in position or the displacement. So delta x is the displacement divided by delta t, which is the time interval. Or another way to think of it, right, remember delta is change in, or final minus initial. So we're going to take our final position x minus our initial x position and divide that by the final time minus the initial time. So displacement divided by time, and again this is all one-dimensional, so this is all we're defining this to be in the x direction, and I hat here is a unit vector that just denotes that this is in the x direction. More on that in chapter 3. So our units here, well, x is a position, so that's going to be measured in meters, and t is a time, so that's in seconds. So our standard SI units for velocity are going to be the meter per second. And just to let you know, so this average velocity, sometimes you also see this as a v with a little bar over it. So in general, in math, if you put a bar over something, that usually means it's the average value. So some textbooks, physics textbooks, like to do this. I don't really, because you've got bars and arrows, and your notation can get to be very, very messy. So I like putting a little AV as a subscript. Okay, so that was the average velocity, so that was the total displacement divided by the total time. Now, instantaneous velocity, well, it's the velocity at a particular instant. So at some instant, how fast are you going, and in what direction? So a good way to think of this, so imagine you're driving along, so you pull out from the parking lot, and you're driving along Lincoln Highway, and you get pulled over by a police officer. And, the police officer comes up, and he says, and you being a good physics student, you tell the police officer, well, surely, officer, I've been driving for a half hour, and I went a total of 15 miles, according to my odometer. So 15 miles in half an hour means that my average speed is only 30 miles per hour. Well, the police officer, of course, isn't going to care so much what the average was. He just cares that at a particular instant you were traveling, 60 miles an hour down Lincoln Highway. So instantaneous is how fast are you going at a particular instant. So, and conceptually, the way to think about this, so you start with the average velocity. Remember, that's the total displacement divided by the total time interval. And imagine you're going to take that, so you're taking that average, but think about taking that average over successively smaller and smaller time intervals. So you're taking your little delta t, so the time interval, and making it smaller and smaller and smaller and smaller and smaller. And what you're going to do is you're going to take it smaller and smaller until it shrinks to 0. So that is the definition of a limit. So this looks very, very similar to our average velocity. Remember, delta x over delta t. Only now we're going to take the limit of the average velocity as delta t shrinks to 0. And if you are paying attention in calculus class, this is exactly the definition of a derivative. So the instantaneous velocity is the derivative of the position x with respect to time. or dx dt. And again, the I hat here, I hat is our unit vector in the x direction. So to find, if we know the position is a function of time, we just take the derivative with respect to time, and that tells us our instantaneous velocity. Okay, so now that was velocity. Velocity is a vector. So speed, however, is slightly different. So average speed is how far you went divided by how long it took. And the textbook, actually, and I like the way she does this, so your textbook author actually likes to use an S to indicate average speed instead of a V. So you'll see average speed is a V quite often, but here it's an S just to illustrate that it is different. So it's S for speed, and AV means it's an average, and this is the total distance we traveled, but divided by the time it took. Now remember, this is not necessarily just the magnitude of the average velocity. So remember, in the previous video there was this little example of the running around a track. So when you run all the way around a track, well, your displacement is 0, but the distance traveled is not. So, and that's how your average speed and your average velocity can actually be very different things. Now, the instantaneous speed, however, is the magnitude of the instantaneous velocity. So if you've got your velocity at a particular instant, you take the magnitude of that, so just the number part, and that gives you the instantaneous speed. And for the instantaneous speed, we are going to use a v. So v with no arrow is the speed, v with an arrow over it is the velocity. So speed and velocity are different things. Speed is the scalar, velocity is the vector. So the speed, and again, this is one-dimensional, so it's just in the x direction. So it's the magnitude. So remember, when we're dealing with vectors, the absolute value signs are the indicate the magnitude. And remember, this is a derivative, so it's the derivative of x with respect to t. Sorry, there's a little typo here. Instead of a delta, this should be a d. So this is dx dt.